Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Welcome. You have found another episode of the Digital Enterprise Society podcast. Thank you so much for selecting this show. I know that you have a lot of podcasts that you can choose from, but this is the show that is designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and every week I co-host this show with Craig Brown. Craig is an industry veteran and a former PLM leader at General Motors. Hey, Craig, how you doing today?
Doing great. Summer's here. Now, the last 3 weeks, I've been in 5 virtual conferences, so I'm almost used up in my virtual conferencing capacity. But the gentleman we have today was at a couple of those and actually hosted one of them. So I thought it was time we in the Digital Enterprise Society hear a bit more about a topic called product line engineering. And Paul is one of the experts at that. So that's what we're going to chat about today. And good news, of those 5 conferences, 2 and maybe 3 of them are planning a fall face-to-face meeting here in the United States. It's absolutely fabulous. It's great to be able to say that. It's been a long haul these last 18 months. And I'm just looking for more and more optimistic signs that, at least in parts of the world, we've cleared this thing and we can get back to normal.
So I agree with you. In the last 2 weeks, I have started to see inquiries from people who are looking for speakers and masters of ceremonies to help run those live conferences. And I haven't seen a lot of that in the last 16 months. So it makes me happy to know that I can be back on stage, either as the master of ceremonies, helping drive that energy for a conference, or doing the opening keynote. Either one makes me really happy to just think about it. I don't have one booked yet, but I'm really excited that it's headed that way.
Do you remember a year ago? It was doom. We didn't know it can't get this bad, and then it got worse a couple of times. But anyways, here we are now. Let's go.
I was going to say, no need to talk about the past. We're moving forward, and hopefully these things are going to open up. But I will say one thing. 5 virtual conferences in 2 or 3 weeks is too many virtual conferences.
Oh yeah. I can't remember who said what, though I do remember what Paul says, because he always has insights that are worth your time. So here we go.
Well, good. Well, we're going to get to those insights right now, because every week Craig and I try to bring to this podcast really interesting interviews and other ideas that are going to help all of our listeners enhance and grow their careers. And today we have Paul Clements, and Paul is the VP of Customer Success at BigLever. And he lives in Austin, Texas, where I live. So sorry, Craig, we're outnumbering you from Texas today. But
that's okay. No problem.
but BigLever is a product line engineering company, and they help companies build product lines in an efficient manner. So Paul, welcome to the show.
Thank you. I appreciate that. Gosh, what a high energy outset to this session. I'm looking forward to the discussion.
So Paul, give us a little bit about your background, and maybe tell us just a little bit about what is product line engineering.
Sure. I've only had a very small number of jobs in my life. When I left college, I went to the Naval Research Lab in Washington and was fortunate to be attached to a research project in software engineering that was exploring the use of what were then advanced software engineering techniques in embedded real-time systems. And so it became clear to me that I was more interested in methodology, how to do things, than actually doing things, to put it bluntly. And so that job was a wonderful first introduction to engineering field and thinking about engineering and how to make it better. From there, I moved to the Software Engineering Institute at Carnegie Mellon, where again, I was interested in how to design systems, how to do engineering in a better way. My interests there were in software architecture, and that led to an interest in product line engineering. I learned about an architecture that had been designed to support a product line. That is, an architecture that was designed to support multiple products simultaneously. And I found that to be a fascinating concept. The architecture was not particularly innovative. It was absolutely fine, did its job, well designed, all of that. So the architecture wasn't the story, though. It was about the business results, the business benefits and gains that working on multiple products as one brought to that company. And so then I was at the Software Engineering Institute for many years. I helped start their product line engineering program there with many others as well. And finally, I decided that I really wanted to go where the product line engineering action really was in the field. And I moved to BigLever over 10 years ago now. And so we're helping organizations roll that out in the real world in real ways.
So, Paul, you and I have known each other for this 10 years or a little more.
Yes.
We crossed paths at General Motors, and I think for our audience, you mentioned you saw an application, an architecture that encouraged product line engineering. What kind of business was that? I mean, what was the end products that came out of that?
That early one, that first one that opened my eyes about this, it was a defense company. It was a Swedish defense company. At the time, it was called Celsius Tech. I believe they've been swallowed at least once, probably multiple times by larger corporations. But their product line was shipboard command and control systems. And in the winter of 1985, says the time frame we're talking about, their salespeople came home from two different directions, both having landed a larger project than this company had ever built before. And instead of being joyous, they were terrified. They said, we'll never be able to do
Don't have enough people, right?
Yeah, we don't have the people. Exactly. We just can't hire that many people. And so they turned to the idea, innovative at the time, to let's not build one system at a time. Let's build both systems at once, and let's figure out what the commonality is, and let's figure out what the variation is. And whereas they needed 200 software engineers to build one of these systems, once they got going, they needed 30 software engineers. It used to take them 7 years. Now it took them 2 years. I mean, just these astonishing numbers.
Mm-hmm. So, car companies, largely driven by constraints in manufacturing, came up with these things of packages of features like chrome and a certain color of paint, a certain kind of leather. And then based on the market behavior, they adjusted those packages. We really didn't call that product line engineering, but was interesting when you and I first chatted was, when we were all talking about embedded software, so I don't want to lose the audience, but some notion of product line engineering, we're going to reuse this pump on multiple cars. We're going to reuse this engine on multiple cars. This was becoming more and more common in the 80s and 90s. And in fact, the successful car companies from Toyota to everybody else, this is a hallmark, right? Is to figure out how to manage components within the context of a family of products. You guys call that, rightly so, product line engineering. And to your credit and the people at Carnegie Mellon, you've codified that into at least a method, maybe even a new way of engineering. And I think that's part of what I wanted our audience to hear today is it a new kind of engineering? I mean, what kind of people practice this? Is it every engineer, or is it just a senior architect? Enlighten us. How do you make it work? And then well, we'll get to how do they learn more, right?
Yeah. What a wonderful question. So I don't think product line engineering itself is a new idea. It's not a new way to engineer. I informally collect examples of product lines, and my earliest one in terms of a manufacturing product line dates to over 2,000 years ago. It's the Terracotta Warriors, Xi'an, China. Over 8,000 soldiers, and each one is different. Each one has an individual face. But they occur in about 21 or 22 classes of figures that have a lot in common with each other. But there's variation as well. And
so you're saying it's just common sense, and we ought to pay attention to it?
Yeah. It's just common sense, and we ought to pay attention to it. Why do things multiple times if you don't have to? Here's what's new. Here's what's different. In about the year 2000, so at the turn of the millennium, a couple of companies brought to the market industrial class, rigorously validated software to help with this. And so whereas before product line engineering was largely, I'll say, an ad hoc practice, it involved making copies and cloning and owning, and can I borrow your thing? That looks like pretty close to what I need, and now I'll make changes to it. Yeah, all that's fine, and it gets you a better start, but it doesn't help you at all in maintenance and sustainment. And so now, with the advent of this automation, this has led to what is being called feature-based product line engineering, and there's a new ISO standard for it. And everybody works in a superset of engineering assets, be they requirements or code or bombs or test cases or models, whatever you like. We all work on a superset, and the automation applies the superset and configures it to each one of the products. So there's no more duplication of content. That's a game changer.
Yeah, and I'm trying to help the audience coming from this from a purely mechanical point of view. We've done this in all engineering disciplines when we were challenged with, we want this common thing, it could even be a test procedure, to be used over and over as we evaluate the next product, right? And then we wouldn't give them enough budget or time, and so then they would come back with, well, what's really, aircraft testing was this way, or what's really different? And then based on what's really different, you fine-tune your testing and validation based upon discovery of weaknesses, right? Well, the more you think about optimizing discovery, the more you think about a product line. And the idea of feature-based is just better. I think what a new engineer might struggle with, if they didn't take the time to learn about where this came from and why it's so important, I would encourage our listeners to do that. You mentioned a standard. What was the motivation for that? I mean, was there competing ideas that needed to be normalized, or was it something else?
There were competing ideas.
Okay.
For several years, we talked about first generation versus second generation product line engineering.
Oh, that'll get confusing. Okay.
Is what I mentioned before, where it was, don't start from scratch. Let's reuse what has been already built, but without the discipline to not make changes to it, but to all collaborate on the thing that's being reused, and without automation to help people use what we've all worked on together. So first generation. Second generation is what has morphed into feature-based product line engineering. And so this effort, it's an ISO standard, but it was spearheaded by NCOSE. NCOSE has embraced feature-based product line engineering as the preferred way of doing things. I encourage people to check out NCOSE's product line engineering working group. It's a wonderful forum where people get together, and they say we need an ISO standard so that people understand the differences between feature-based PLE and the other kind, which we hope is...
Well, and I was in a debate earlier this week about standards, ISO standards, and a colleague used the term, well, it'll be mandated by governments and therefore you'll have to follow it. And I'm like, well, okay, hang on. It doesn't actually work that way. but do you envision it being mandated, or is it just a way to get people to talk clearly with each other?
I don't know if it'll be mandated or not. I don't know. I can think of worse thoughts, to be honest. Where product line engineering applies, and it doesn't always, but boy, it does a lot. Where it applies, actually being able to talk about it in clear terms so that we can start the conversation at an advanced stage and make more progress. I think that's going to be one of the biggest uses of the standard.
It seems to me things like autonomous driving could use some help, right? There is so much confusion over automated driving or replacing the driver or bigger established companies, be it Toyota or General Motors, they're more careful. They say things like, well, we're going to give you things that help you drive on the highway, but we're not going to replace you, right? Right. So I like to think that features in the future would become clear to everybody, including the consumer, which is where I'm going with my point. And if standardization helps the consumer understand, when we say Super Cruise, we mean the following everywhere. Yeah, that's going to help a lot. Today words get overloaded. There's way too much advertising and marketing chutzpah, and it's confusing. So maybe standards help it better for both the consumer and the producer. We just get back to clear communications.
Yeah, wouldn't that be nice? I think you're right. As you know, we work with General Motors. We also work with other automotive companies as well. And we are finding that some of them are taking autonomous driving as an opportunity to come back and say, all right, let's get our engineering house in order, because this is brand new. It's not something we're evolving really that's been around for 30, 40, 50 years. Although, as you know, the antecedents of it are there, the cruise control that keeps you from running into the car in front of you. right? That's an early form of autonomous driving. But people are saying there is so much variation in our autonomous driving systems. Let's get a handle on that. It's the sensors, it's the behavior you want, it's the physics, it's the what we're going to avoid and what we're going to let the driver do. So we can't just build an autonomous driving system. We're going to, of necessity, build a family of Lord knows how many variants of an autonomous driving system to put on our family of cars.
So this brings me back to this thought about, I think it was 3 years ago now, Paul. I'm trying to remember. We were in Detroit, Rochester Hills, and you were giving a talk about predictions that didn't come true. and what I remember was engineers being replaced by computers, right? Or something like that. We got a lot of computers. We got a lot of computer-based design, computer-aided everything, right? What are your thoughts about this? Are computers eliminating engineers, or are we creating the need for more engineers, or maybe we do our job differently instead of being administrators?
That question in its general form is for people with bigger brains than me, but from a product line engineering perspective.
Oh, nonsense. You've been watching it for 40 years, right?
From a PLE perspective, I can tell you that PLE is not about replacing people. It is definitely not about that. It is about helping people concentrate on higher value work rather than lower value repetitive work. Think about a product line built the old way where people have made copies of things, and now I want to make a systematic change to that. Some new thing happened, and I need to update everything. Well, I'm going to have God knows how many teams of people doing essentially the same work, and they look over their shoulder and say, "You're doing the same thing I am. Why are we both doing this?" And it's just demoralizing. And so PLE is about letting those people work on the innovative parts, the new parts. Nobody under feature-based PLE works on stuff that's already been done. They work on the new stuff. And so in the engineering world, I think we're making people even more valuable.
That's interesting. And so we could be more innovative. And if you needed no other motivation, it's to increase your innovation game. So that's interesting. Okay. So what about the biggest failure? Somebody who's tried to do PLE and they just didn't get it, or they did it really wrong for whatever reason. What biggest failure have you seen?
I would love it if we could write some papers or point people to the standard and say, off you go, good luck. And then we all sit on the couch eating potato chips. That would be my idea of a great professional career. However, it doesn't work like that. Really adopting this is going to require some organizational change. And as you know, and probably all of our listeners know, organizational change, it's hard. It's just difficult to do that. There are a few different processes involved in product line engineering. There are a couple of new roles that need to be filled for product line engineering. Who owns the features, for example, in their definitions? And so that's going to require people doing things a little bit differently than they do. And that's organizational change. And not paying attention to that, I think, is the source of the biggest failures to adopt this and roll it out. The technology's there. The technology's easy. It's the people that are the hard part.
So for our listeners who are embracing PLE and see the standard, and you're wondering what one measure of success is, one I saw over and over was senior management, probably an executive level, gets it, and then supports you when you have to tell one of the chief engineers of a series of products. So you got multiple products competing for your attention, and one of the chief engineers says, just do it my way. The executive over them has to say, no, we're doing it in the product line so that everybody benefits. And if we have to adjust somebody's schedule, like the lead guy typically, well, then we're going to adjust your schedule, or we'll adjust your feature content on your release plan. And so when you hear that discussion from the executive to the chief engineer, you guys are serious about doing product line engineering. And as you know, Paul, and our colleagues that are still at General Motors, they have that support from the top. It's actually quite interesting to watch that dynamic unfold. So so get the roles right. Okay. Who's the most successful? I mean, is there an industry? You don't need to name companies, but I'm curious, what industries just click and get it, and maybe what industries struggle getting it?
Somewhat to my surprise, aerospace and defense gets it. They get it a lot. In the early days of PLE, it was thought that they would never fly in aerospace because, the requirements are too rigid, and everything has to be handcrafted and hand-tailored, and the government, blah, blah, blah. No, aerospace and defense They're leading the way on this.
What was their catalyst? Why?
Interject. Because of efficiency, because of relentless cost savings and cost avoidance. One of the case studies of feature-based product line engineering that we publish a lot, you may have heard the talk in one of the virtual conferences you mentioned, Momentum, a couple of weeks ago. General Dynamics, they are about to realize the $1 billion mark in cost avoidance, all due to feature-based PLE. That's huge. That's just enormous. We're sitting at $967 million in measured cost avoidance right now over the life of a 12-year product line. So you think the government doesn't love that?
Well, yeah, but you're reminding me of an interaction we had here at it's the Ground Vehicle Command, so it's the Army. Okay. About a decade ago, a little more than a decade ago, myself and my counterpart from Ford were invited to the meetings to talk about really about simulation methods, but we got into a discussion about product line efficiency. and the person who was in charge of the command or the assistant commander or whatever, they were colonel, they said, and so it's a decade ago. So we're 10 years after 9/11, right? And it was really interesting what they said. They said, we don't worry about making our tire strategy or our suspension strategy common and then reused across platforms. When we were threatened in 2001, money was not an objective. We just opened up the spigot and we built, tanks and troop carriers and everything else that had unique engineering. So it's interesting you mentioned General Dynamics because they were one of the suppliers, and I found it a really interesting discussion. They were asking Ford and GM, well, why did you guys do this? Why, the beginnings of better product line management, and we're all about, well, why would you redo the wheels? So wheels are wheels, humans are humans. They don't much change from one vehicle to another, other than a little bit of dynamics, and so. It was a really interesting exchange. It wasn't adversarial. It was, why aren't you? And they said, well, there's a bigger risk. And at that moment in time, we were all about going and getting the bad guys. So I get it, right? But yeah, I agree. There's huge cost savings. The car companies know this inside out. Consumer product goods, like what Procter & Gamble and others do, they get it. Interesting. Well, have we missed anything we should talk about?
Well, I just want to follow up on that conversation that you described. It would be interesting. And so if cost wasn't an issue, I bet time to delivery was. So especially
right.
out there. And so once again, I would point to PLE and why start from scratch? Why would you do that when you can, whatever they were building wasn't completely unique. And so three things that PLE gives you: cost, schedule, and quality as well. So we've been talking a lot about cost, but I just want to plug the other two also.
No, you're right. And I remember a strategy discussion inside the company decades ago, and it was about all three of those, and they wanted improvements in all three. And I said, well, the only way you're going to do that is by reusing parts. So get on with it, right? Whether it's a mechanical part or a software part, right?
Right.
So what have we missed anything else about PLE that you'd like to share with our audience? You mentioned feature PLE. Maybe expand a bit more on what that feels like when you're doing it well.
Yeah, if people in the audience are members of Incosi, you can go to the Incosi store and download a primer.
So spell it out for the audience, just so for those that don't know Incosi.
It's the International Council of Systems Engineering. And it's a professional society, I think the granddaddy and biggest professional societies for systems engineers. And I'll plug them. If you're not a member, you ought to think about it because they have an enormous number of resources, one of which is a primer on feature-based PLE. It's a free PDF. It's a glossy brochure, so it's not a weighty tome. And you can read about the basics, and there's a section in there that says how you know if you're doing it and how you know if you're not. So I would suggest that as a starting point. There are lots of other places to go. The PLE Working Group of Incosi is a wonderful resource. And I'll plug my own company, BigLever.com. We have a lot of educational materials about what is feature-based PLE and why should you care.
So that's my last question. So are you just advising people or do you, I already know the answer. You guys got tools that help this, right? You automate the creation of a feature set or a collection of features for a product. Why don't you describe that, and then we'll go back to Thom after that.
All right. Okay. Yes, lovely. So remember I said that one of the hallmarks of feature-based product line engineering was a piece of automation. This is the thing that changed and brought about feature-based PLE, the existence of these automated industrial strength configurators. And BigLever builds one of those. It built one of the first ones, if not the very first one, back around 2000, 2001. And so this is the technological underpinning of the method. And so, that's what BigLever does. But we also help organizations with methodology and organizational change, whatever they need us to do to help them be successful with this paradigm.
To wrap this up, we talked about PLE, the guys at GM, and a few of us have retired now, with all of the big PLM and ALM vendors about that time frame 20 years ago. And it was just amazing how they at first they didn't understand, and then they understood, and then they said they already did it. And anyways, now you'll hear these 5 conferences, every one of them is talking about a product configurator of one sort or another. And so to the audience, when you hear product configurator, the genesis of product configuration comes from product line engineering. It really does. And so, go learn more. And if you got questions, give Paul a call or give me a call. Thom, back to you.
So Paul, I want to ask you one question before we leave. One of the things I like to do at the end of many of these episodes is get a little tidbit of career advice for our listeners, because a lot of our listeners are still young in their careers. They're trying to figure out where to go. And kind of in the introduction and when you talked about your career, you talked about the fact that you were at the Software Engineering Institute at Carnegie Mellon, and then you saw this growing. You decided to make the leap to a company, and you've been with BigLever ever since. If somebody sees something, like maybe it's PLE, maybe it's something else, and they're like, ooh, that looks interesting, and it's not exactly what they've been doing. Maybe they're making a move from the education world to the private sector, or from government to private sector. How does somebody make a calculated move like you did 10 years ago and then be able to parlay that into a real successful career in a new area?
Oh, goodness, Thom, I have no idea. All I know is that I've been one of the lucky professional people on the face of the planet to be able to have the trajectory that I've had. I will tell you that I realized a long time ago that I really liked observing and teaching more than I liked practicing. And so people can look at that and say, yeah, right. Teachers teach, but doers do, and this guy can't do. Guilty as charged. Fair enough. I just find I like helping people do things more than doing things. And so towards that end, this is what has propelled me in my particular trajectory. I've always gone where it was the most effective place to help people get better at what it is that they do. And towards that end, I would like to put a plug in for people who are wondering how that works. Figure out what it takes to be a good teacher. So concentrate on presentation skills, on speaking skills, on writing skills. I think these are woefully underemphasized in our field, and it's a shame. And I hope that's sort of self-evident, but it doesn't always seem to be. And I've found that people who are able to string words together are a lot more effective and can effect more change than those that have a struggle with that. So concentrate on that part of your professional persona.
Well, I think both pieces of that advice. Number one, we talk about it a lot because my background is communication skills and how do you relate to people and how do you connect. So the writing and the speaking stuff is so important. I tell everybody, I don't care if you ever want to be, doing a lot of speeches or not, joining a Toastmasters club is one of the smartest things someone can do for their career because it's going to set them up to learn how to be a better communicator. And the other thing you said was going out there and teaching and helping others. The famous Zig Ziglar said it best, and that is, you can have anything you want in life if you make a career of helping other people get what they want in life. And that's just, I think, another way of saying what you said. And so I think that's wonderful advice. Thank you, Paul.
Nice.
So thank you, everybody, for tuning in and listening. Really appreciate that you're here for another episode of the Digital Enterprise Society podcast. We want you to join us every single week for more thoughts, ideas, and information in and around product lifecycle management. Remember, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.